Let's double check, because you're probably not going to be you're finding the 5-number summaries by hand from here on out. You're going to be using the calculator. And I get asked this all the time, Mr. Clark, how do you find the mean? How do you find the standard deviation? 5-number summary using the calculator. So this is probably one of the most important steps you'll learn from the calculator that will follow you throughout this entire school year. First thing we need to do is hit the home button. I need to just reset my calculator. So everybody reset it by hitting the home button right here. Home. And say new. So hit number 1 or scroll over to new and hit enter. Now here's my options. In statistics, we're very heavy on add a calculator, add statistics, or add list spreadsheet, and add data. These are the 3 options we'll be focusing on in this class year round. Now the first thing we want to do is just like when we had the Google Sheets and we made a graph, I need to first enter in my data in a spreadsheet. So for the calculator, we're going to go to the number 4 option where it says add list and spreadsheets. Look for that icon there that actually looks like a spreadsheet. Let me go back to the calculator. I'm going to say number 4, add list and spreadsheet. Everybody should be here. The most important thing, calculator is going to anticipate you doing some kind of calculation on here. So it's going to give an error message if you kind of log out. What we need to do is label our columns. If I don't label them and have multiple columns, how do I know which one's which if they're all going to be blank? Or I think the 84 is labeled like X1, X2, X3, etc. So it wants you to label the columns, and you have to label the columns. Otherwise, you'll get some kind of message that says, hey, your columns aren't labeled. I recommend labeling something relevant. And since we're going to use the McTofu and Moose Burgers data, I'm going to type in, I guess, Moose for column A, hit enter, go on column B, and then call that tofu. Most of the time we'll be calling these like data or something, but if you have relevant information put in there, go ahead and keep that. So moose and tofu.
It said to use something random or relevant?
Relevant, like moose and tofu, something specific. Like data 1, data 2, you have to remember what is data 1 and what is data 2.
Oh, why did I never see this?
So I would put a star here. Make sure you know to label the column. And if you forget, it'll remind you. Now go ahead and enter the data for all the salaries.
Thank you.
I want to keep within this document, so I'm not going to hit menu and do something else because then it'll ask me, do you want to save and quit, and then I'll start all over again. I want to create another tab, and we're going to have to do this so often in this class, it'll be like second nature. To create another tab, or to insert another tab, I'm going to do Control-I. So once you have your spreadsheet, do Control-I. And be like, okay, what type of tab do you want to open? And I'm going to do a calculation on that data. So I'm going to do add a calculator.
Control-Add?
Control-I.
I?
Yes, right here. Control-I, add calculator. Control-I. Control-I. Oops. Now it gives you a blank page where you can do some kind of math or whatnot. But for us, we're going to calculate all of our information, our 5-number summary, our standard deviation, our mean for this spreadsheet. I'm going to go menu. So everybody hit menu. And the benefit of the Nspires versus the 84s is that everything is grouped together. There's only going to be 2 spots we go to in this class when we hit menu, unlike 5 for the 84s, unfortunately. We're going to either go probability, which is later, or what kind of class is this? Statistics. So menu, number 6, statistics. I'm going to do a stat calculation. So number 1. And then, unfortunately, they don't call it the 5-number summary because it has a whole bunch of other information in it as well. But here's where you're going to go to get all of your data printout for your stuff. 1 variable statistics. So menu 611. Mr. Clark, where do you do the 5-number summary? 1 variable statistics. Keep that to default. Just say 1. And here's where I'm going to select which of those columns I want to run that calculation on. We'll start with Mooseburg. Hit OK. And then there's my entire printout on all the things they can run statistically on that data. X bar, what does X bar mean? Average or the mean. So if you look down, your average for moose should be 134.4. Standard deviation, which will become important later in the next unit, but here it is right here. I'll go ahead and just introduce it. That is your S, X, and sigma S. Both of those start with an S, just like standard deviation. One is referred to population, one is a sample. You don't have to know that just yet. N is 10. What do y'all think N means?
Is that the number of terms?
Yeah, your sample size. So my number of numbers. And then finally down here, there is my 5 variable statistics. Where check your minimum. Is it 110? Q1, 123. Median, 133.5. Q3, 144. And a max of 160.
My text literally sent.
So this is what you're looking at. X bar is your mean. Standard deviation. Here's your 5 number summary. Everybody checking their 5 number summary. So if I circled it wrong, now it's time to make the corrections. All right, now let's do the 5 number summary for tofu. Menu, where did I go? What class is this? Statistics. What I'm going to run on those numbers? A stat calculation. And which of these is the printout?
One variable.
One variable statistics.
Do we
Correct.
have to make a new page?
No, you can do this right on the bottom. So as you see, I do OK. I'm going to change my list to tofu. OK, and it prints it out below the other one. So if I were to scroll, there's my moose, and here is my tofu. What was the mean? The average? 145.9. Your X bar. What is my minimum? 100. My Q1? 15. My median? 24.3. My Q3? 132. And my max is 360. So again, if I circled it, that's just wrong. Now's the time to change it. Okay. Now what if we want to make graphs? Can our calculator make those nice histograms and box plots? Kind of, sort of, yes. Here's how you pull it off. I'll need to open up a new tab. So how do I do that? Control I. And here's where it could get kind of confusing. We're not going to go add graph. Because there's a quadratic. That should remind you of algebra. We're not in the algebra class. Which one of these do you see that looks like a histogram? 5. So here is where we have our graphs and stats. I know it's not, it should be add stats graph or something like that. Unfortunately, it's just add data and statistics. But go with the picture. There's my nice little histogram. So click on 5. And it randomly assigns these plots on your page. What you need to do is set your axis. For this, I'm just going to set the x-axis to, let's say, moose. And put them down there. Now, what kind of graph does this look like? Dot plot. I got dots. It is dot plot. Correct. How do I change this to a box plot or a histogram? Well, now I'm going to go to Menu, Plot Type, and there are my options. If I select histogram, it does the best it can to make a histogram. Notice these have spaces. Histogram does not. So you should kind of visualize this being pushed together. There is a way you can manually push it together, histogram, but then you start screwing things around and mess things up like this. And I'll just keep it the way it is and visualize the histogram. I could change this to Menu, Plot Type, Box Plots, and there is a pretty good sketch of a box plot.
So how do you change it?
So again, make sure if you just have the dots randomly on here that you assign the axis to a value. Okay,
I'm sorry, can you re-explain that slightly?
And we're doing moose right now, so there's moose. Now there's my dot plot. If I go menu, plot type, box plots, there's my box plots. And now let's look at this box plot. Again, some of you are missing maybe shape. Would you say this is symmetrical or slightly skewed?
Symmetrical.
It looks pretty symmetrical. Box plot looks pretty symmetrical, yes. Not perfectly, but I say it would be approximately symmetrical. Because perfectly symmetrical, these will all be equal lengths. But this is pretty close, especially since I have my median right down the center of it. Change moose to tofu, and there is the box plot of my tofu. What do you notice about tofu? There's a potential outlier, and it looks like it's slightly skewed which way?
To the right.
To the right, but let's see. Let's do menu, plot type, let's change it to a histogram, and yes, I see like a tail action possibly going on here. I definitely wouldn't say it's approximately symmetrical. My best guess would be slightly skewed to the right. So let's go ahead and look at some more graphs here. And again, FYI, I'm going to be going over this worksheet and what I expect to see in the answers. Look at the graph. Which of these graphs is different? Yes, I know technically they're all different, right? None of them are exactly the same, but one of these stands out more different than the others. Summer. If you were to look at the axis, looks like it's number of days versus the average wind speed. Which of these do you think has the least amount of wind speed? Which of these is not as windy? Which of these is not as windy as the others? Here's where you might want to look at the spread. My spread with fall is between what? About 5 to 6, 5.5, right? What's my spread for the winter? My range is about from 0.5 to 6.5. What is my spread for the summer?
That one's different. That one's different.
Ah, from 0.5 to 3. And then what is my spread here for the winter? 1 to 6. So one of these is missing a 3, 4, 5. And that is summer, right? Looks like it's not as windy in the summer as it is with the other months. Also, looks like all of them are skewed which way?
Right.
To the right, correct, towards the tail. Looks like I have a tail skewness here. Even this one, even summer, it looks like it's slightly skewed to the right. Now, what if we had what kind of graph is this? Stem and leaf. Now, like I mentioned, stem and leaf is a lazy way of writing your data. This is even a lazier than you can be, where it represents two sets of data. So notice how the stem and leaf is created. It has the northeast and midwest, and it has 88, 90, 93, 96, 97, etc. But then it also goes this way with south and southwest, 88, 87, 87, 85, 91, 92, 93, 94. It's backwards. But hey, that's the way you could pull off two sets of data on a stem and leaf. You go left and right. But if you want to visualize the shape of the data, what you can do, like I mentioned before, stem and leaf, is rotate it. So I'm about to rotate these like so. And now I kind of turn them into an impromptu histogram. Let's look at the south, the southwest. Would you say it's approximately symmetrical or skewed? Yeah, approximately symmetrical. What about northeast and the Midwest? Skewed to the left, correct. It looks like I got a little tail going on here to the left. So there's my shape. Let's start with the C, the center. Since it's symmetrical, which center would I want to look at? The mean or the median?
The median.
Symmetrical, I'm going to look at the median, mean. You want to look at the mean. If anything, all else possible, look at the mean. You'll get this down when we do the next unit with the normal curve, because it all talks about mean and standard deviation. But if you see symmetry, mean. But let's go ahead and let's also, you wouldn't be wrong if you also grab the median as well. What do you think is the median for the south and west? What's about the center? Yeah, roughly 90 something, correct? 97. Just say about 97. Now here, northeast and the Midwest is skewed. I wouldn't take the median with the skewed because which way does the mean get pushed? Towards which direction? Towards the tail, the skew, or towards the majority of the data?
Tail.
It gets pushed towards the skew. It wants to hang out towards the majority of the data, but it's being pushed by our tail. It's being pushed by the outliers. Hint for number 5. So with it being skewed, I want to then definitely take the median, and what would you say the median is roughly here? About not 10, but you think it's 102. 102, 103, roughly. 90, 96, 97 roughly here. I think the median would be more this way. But again, if you say about, if you're guesstimating.
Doesn't it make a little bit more sense to say that the tail pulls it towards it?
Sure. Think of the tail, think of outliers like gravity. They're pulling it towards me. Yes. You're right. The mean, yes. They pull the mean around. Let's see, what do we else missing? We did unusual features. Do we have any unusual features? Any outliers with this one? No, it doesn't look like it. Any unusual features here? Any gaps or outliers? 8. Maybe 8, I don't know. So if you want to say there's a potential outlier at 8, okay. Otherwise, you would say normally there's nothing really that stands out, so I don't see any potential outliers or any potential gaps and holes here. And then finally, spread. So I would probably take, again, if it's symmetry, the spread is the standard deviation. Otherwise, you'll want to use the range, but we'll just go ahead and stick with the range here. My spread, my range will be between what and what?
80 and 100.
Okay, 80 and 100, but if you wanted BS, be specific, you would say 85 and 106. Right? What's the lowest number? 85. Highest number, 106. What would be my spread here? Okay, 88 looks like it's the lowest number to 114. 114, 114. So yeah, there's our cuss and BS.
Mr. Clark, why is there like 2 9s and 2 10s at the bottom?
Probably just,
The other side.
so like why the 2 9s, 2, probably for sake of room.
Okay.
Instead of just making it like this, and these are like a long out, so in order to like spread things out more, they, looks like they divvied it up between anything bigger than 5 is up here, anything below 5, so they cut it in half. Because if you find out you have a lot of 9s and 10s, then maybe cut it in half, that way you can spread the data out more.
Okay.
So it'll be like changing your increments in a graph. Like, oh, my graph is too constrained. Like, let's see, if I do this, maybe I want to push this together, make my increments a little bit different. Maybe I want to spread the increments out so that I can look at my graph differently. Roller coaster rides want a coaster that goes fast. There are 2 main types of roller coasters, those with wooden tracks and those with steel tracks. Do they typically run at different speeds? Well, somebody did the research for you, and they created a box plot to represent the results. Compare the speeds in woods and steel roller coasters. So let's start with cussing.
What?
And make sure we're specific. So what does the C stand for?
Center.
Center. Would you say the center is about the same between the steel and wood?
Yes.
Approximately.
Approximately. Well, what are you looking at as far as the center?
The line.
Which line?
Median.
The median line. Very good. So I would say, are these median lines about the same?
Yeah.
Yes. Roughly. Not exactly the same, no, but I'm using the word about, so I'm good to go there. The next thing. Any unusual features with steel?
Outliers.
I have potential outliers. Yep. Potential outliers, looks like I got potentially 4 of them. What about the wood?
None.
None.
No outliers.
I don't have any outliers with wood. Or at least I don't see any. Next, S. What does that S stand for?
Specific.
Shape.
You're aware.
So notice the shape of steel. Does it look like this could be skewed or roughly symmetrical?
Roughly, it could be skewed.
Yeah, it's probably going to be skewed. Right now it's kind of hard to tell, but if I were to rotate this, look like here's 0. So I'm going to rotate this way. It looks like it might be right skewed. And what about the wood? Would you say it's skewed or roughly symmetrical? Yeah,
I'd say it's roughly symmetrical.
it looks roughly symmetrical. I would say so.
What does the C and U stand for again?
The what? Center, unusual features, shape, and what's the final S?
Spread.
Spread. Is the spread different from steel and wood?
Yes.
It's very different, right? Which of these do you think is more consistent, steel or wood, as far as speeds?
Wood.
Wood. I got a nice, close, compact spread. Why do you think the steel might be so odd, like it is? Have so many random outliers? Okay, maybe different types of steel. What do we know about steel when it's outside?
Rust.
It can rust, so it's affected by the weather. Also, when it rains, maybe it's slipperier. What would you suggest be changed about these histograms to make them easier to compare? Something's wrong here.
The numbers at the bottom, because the men's is 12.5 in the middle and the women's is 10.
Very, very good. So as this slide points out, side-by-side box plots or histograms or anything should be the same X and Y scales to compare them. Are these the same? No, it looks like this was manipulated so that they look like they're the same. But if I were to readjust one of them, I should see that there's a difference. So don't manipulate your data. This is a big no-no. Make sure when you're comparing them, the scales, the axes are the same. Y looks good, but the X is off.